This is one of these roughing cutters, these hogging end mills, so we'll see how that works. I'm going to be pretty aggressive with it, but certainly not as aggressive as a CNC machine. Okay, I'm getting close to the line, and now I'll take this cutter out and finish up with a standard 3/4 inch Niagara cutter. I've changed end mills. I'm at a 3/4 inch finishing end mill. Now this is 3/4 of an inch here. Now you can go by your layout line, or I could go by my layout line, but a more accurate way of doing it is to touch off. So I'm bringing the cutter so it just touches the work, locking the quill, and then moving this away, and I'm going to crank the knee up. I've zeroed it out. Crank the knee up 750 thousandths, but in fact I'll go 740, so I have a 10 thousandths finish cut. So up I go to 740. Now I'm at the correct depth, less 10 thousandths of course, and I'll start milling, and then I'm also going to mill to a dimension on the two ends. And I'll show you how to do that. This end is to be 5/8 thick. That's right now it is. Gotta get the chips off of there. Did I say 5" 0.625? That's what I meant. I'm at 675 thousandths approximately right now, so I'm just going to do the math and then feed in that amount looking at my digital readout, and then this will be the right thickness. Or you can go to that layout line. Let the calculator do the math. I got 53 thousandths to take off, so I will zero out the x-axis on the digital readout, and I'm moving 53 thousandths. Unlock the table. 53 thousandths. Lock the table. Remember to always lock the table in the direction that you're not moving. And I'm at, let's see, 626, plenty close enough. Now I'm going to go down to the other end and take a light cut, measure it, determine how much needs to be taken off, and then I won't show that because it's the same thing as this side. And remember that you get a better finish climb milling. So usually my final pass is climb milling. I guess I forgot to tell you that, remember that I got 10 thousandths more on this dimension, so I'm raising the table that last 10 thousandths, and I will cut back and forth again until I get to this side. And that's my finishing cut. I feed a little slower than usual for a good finish. I guess I will show that after all. So I'm done down here, and now I need to measure this and determine how much to take off to get the correct thickness right here that where I'm gripping it. And it's supposed to be 750.750. This was 790. I wanted 750, so I have 40 thousandths to take off, and I'm taking 30 thousandths off with conventional milling, and then a final pass of 10 thousandths. And now 10 thousandths more. And this is climb milling, which always gives a better finish, I've found. And never mind the long sleeves. It is very cold down here. I know that you're better off with short sleeves, and I'm telling you to wear short sleeves, but I'm pretty cold-blooded. I'm at about 752, just a little bit over 755, but that's good enough. That's within 5 thousandths, and it's not a critical dimension. Now I'll take it out, deburr it, go over to the bench, and decide what I'm going to do next. Thanksgiving is just about here, and I'm very thankful for my wonderful shop and all of my great tools, and taking my relatively new used Mitutoyo mic. This is supposed to be 500 thousandths, and you saw how I did that by cranking it all in, and let's see how close it is. I'm within 3 thousandths. A real thick human hair or 2 thin human hairs. So all these dimensions, this, and this, are real good. Now again, if you're making 2 of these, mill them together. Now my next question to myself here is, remember this is cold rolled steel with a lot of stress. Milling this out caused this to bend, I think. So let me see if we can determine how much and if we need to do anything about it. You know what, I didn't mean to be frivolous about being thankful here, because I'm more thankful for good health, a fine family, prosperity, living in America, and all of those good things. Okay, I took a file, and I know that most of you are too, because the people that watch my videos tend to be well-grounded, but cleaning that up now, laying this on a surface plate, I have here some feeler gauges, and there's a 2,000th. Look, it goes right under until it comes out to the end. Here's, well, I'm going to bypass the 3 because I did that off camera. I'm not going to pretend that this is spontaneous. Here's 4 thousandths. Even that fits under there. Doesn't go as far toward the end, but we got 4 thousandths or more. So now let me do it one other way. I'm going to put some dye on here and then rub it a little bit, and you can see the high spots and the low spots. And then what should I do about it, if anything? So laying a straight edge on here, and if I hold it up to my fluorescent lights above me, I'm doing that of course off camera, and wow, can I see the light under there. My oh my, I wish I had a surface grinder. I put layite dye in there and it's now dry. Really, many machinists would use Prussian blue, but this is so messy. And I think you recall the story I told about the apprentice up in Joliet putting this on a black toilet seat of his big burly foreman there, and the trouble that caused. But then again, that's another story. This is 500 grit wet or dry, brand new, so it's going to lay pretty flat. Just a little bit of that, and let's see what happens. Look at that. You can see that that's high, can't you? So it's only touching on those points. Now it would just be wonderful to have a surface grinder and surface grind that off. But what I'm going to do is to mill, just takes ever such a light cut off of that, and it's, you know, it's only going to be 5 thousandths, and that's going to change this dimension. But I guess I don't care. And then for that matter, maybe it wouldn't even matter if I left it the way it is. But do you recall an hour ago when I said there's stresses in cold roll steel that you don't have in hot roll steel, or I don't know about tool steel, but and some of you are probably going to make this out of tool steel. But the whole point is here, this could have been normalized or annealed, and that those stresses would have gone away. But that is another major step, and it causes such scaling on there because I don't have an atmospheric type furnace where I can get rid of that. So there's a lot of scaling, and that's not something I want to do, but I thought this was a really good thing to show you here. Now, if this was taken out of a larger block of steel, you know, you probably could compensate for that by sawing some on each side of it. But we've removed a section here that had the stress in it, and then that caused it to bend. So off camera, I'm going to take this back onto the milling machine, and with my best cutter that's still in there for that matter, I'm going to mill just a few thousandths off, and then I'll take it and clean it up on some emery cloth. Or I should say wet or dry, real fine stuff. See you in a few minutes. I guess I will show just a little bit of this setup here, because good workmanship and just being careful with everything you do adds up if you want an accurate project. So I took the time to clean the vise out. It was so full of chips, and wiped it out And then I always rub it with my bare fingers too, because then you can feel any chips. Then I put a parallel in there, and then the work all wiped, because just one chip under the work or the parallel can throw you off. Then tighten the vise down, and I will bring the cutter over and take that light cut that I spoke of. To find my reference here, since the middle is the low spot, I'm just bringing that down till it touches, locking in the quill, backing it off, increasing the depth by, oh, 1/1000th or 2, and then start milling. And very slow feed so I get a decent cut. I've deburred it. And then with this paper, and make sure this is clean, spend a few minutes doing this. Could I have just taken this on the belt sander? I suppose, but I don't consider that very accurate, but you know, maybe it wouldn't matter. Now this is the 2000th, and you can see it won't, I don't have a 1000th, but it doesn't go in there, so it's pretty flat now. Now did that change some other dimensions? Possibly, but I can't be worried about that. Next I'm going to lay this angle off, and it says 28 degrees, so you can use a protractor if you're in the mood, or from point to point, so it's 250 thousandths over, and we connect it here with the line that is 500 thousandths. So with my square set for 1/4 inch from this direction, I'm working left-handed now. Right there, I'll lay a ruler on there and connect that with this point right here. That's just a little bit awkward to do. Use the protractor if you're in the mood. 28 degrees. I'm going to lay out the position of the hole right here, and I put some fresh dye down here as drying, but laying it upside down like this, and I'm looking at the drawing, and you can see that the hole is located 3/8 off of there, which is also 3/8 off of the top. So this being set at 3/8. Now maybe this doesn't even need to be laid out. That can all be done on the milling machine, because I'm going to drill and tap it on the milling machine, but just to illustrate, because some of you don't have a milling machine, you'll be using the drill press. And this is set for 1/2 inch, which is half of the thickness. So, looks like that. And I'm not going to center punch it. You center punch it if you're going to do it on the drill press. Now back to this when it dries. And finally, here's that layout. So I'm ready to drill and tap. Tolly told me that in modern drawing they don't necessarily show everything in all the views, but you know, the hole is there. Well, what a hole that is. But the thread is a 5/16 24, and that's a letter I. So I'm going to drill it with letter drills. And there is the letter I.